Alright, so for this presentation we're going to be talking about orbiting and projectile motion. So before we get started with talking about what orbit and projectile motion actually are, it's important to make a point about what it means to be weightless. Now, there's actually no object that is weightless, no matter where you are in the universe. I know if you go to space, obviously you're going to float pretty well freely, but you're in fact not 100% weightless, even though you may have nearly zero weight. It's never going to be exactly zero. So the reason this is because all objects have gravitational pull towards each other. You have gravitational pull towards the book that's on the desk next to you, and the book has gravitational pull back towards you. But you can't feel that pull. You're not moving towards the book's not moving towards you because our masses aren't big enough. So the smaller the object is, the less the gravity. So something like Earth is enormous, which is why we can feel the gravity of Earth. Now, for gravity, the mass has to do with how big gravity is, but also the distance you are from an object. So if the farther you are, the less gravity is going to be. So when you get out of Earth's atmosphere, you're going past the point where Earth's gravitational pull is strong enough to actually pull you in. And that's why you get to be somewhat weightless. But no matter how far away in space you are from any planets or stars, you're still going to have their gravity pulling on you. It's just enough that it's undetectable. Just like the book on your desk. You have gravity with that book, you just cannot feel it. So when you get into space and you get far enough away, you still have the planets and the sun and whatever else pulling on you with their gravity. You're just not close enough that you can actually feel that. So you still have that slight attraction because you still have mass. If you have a mass, you have that gravitational attraction, but you just can't feel it because you're so far away. So nothing's actually technically weightless. Which leads us into orbiting. So I'm going to guess that if you've ever heard of orbiting, you've heard of it because of space. We talked about space last year, how we have satellites that orbit Earth, and the moon orbits the Earth, and there's things that consistently go around. The Earth goes around the sun. So we definitely talked about orbiting in the past in Earth science. All objects that are orbiting are in free fall. So the last presentation you should have listened to said that free fall, the only force acting on that object is gravity. So if you drop a ball from the top of a building, it is in free fall. In space, when there's a satellite or something orbiting around Earth, basically what happens is that object has been put at the exact right speed, the exact right position to just constantly be falling. So it's almost like it's been shot at an arc, and as it falls, it's just going past the Earth just a little bit, and it continuously falls. So Earth is pulling it towards it, but it's just at the right arc. And I'm going to show you a video to help explain this when we're actually in class, when we're recapping this. But it's just falling past Earth every single time. That's why it continuously goes in that circle. So it's always moving forward, but it's creating that curved path because it is in free fall. The force, centripetal force, is what keeps that object in orbit. So we talked about that last presentation, with centripetal acceleration being when you swing the bucket around with water in it, that's a centripetal acceleration. It keeps the water in. It's the same concept. It's the force and acceleration of it going in that circle. And again, I'll show you a video in class just to make sure we've understood this. Projectile motion. So anytime you have an object that has a curved path, when if it's been thrown, if it's been propelled near the Earth's surface, that's going to be called projectile motion. If you've ever heard of projectiles, and be like, if you shoot a gun, you're shooting a projectile, or anything you're shooting, arrows, guns, slingshots, you're shooting a projectile. If you've ever heard of, and I get this brought up every single year, projectile vomiting. It's when if you vomit and it goes out and then down, that is projectile vomiting. Anything that is going forward but then falls to the earth with a curved path is considered projectile motion. So dancers that leap, they go up, take the curved path, they go down. You throw a baseball or any kind of ball, it's going to go forward and then create a curved path because gravity is bringing it downwards. grasshoppers hopping, arrows being shot from a bow. If you are someone who has ever shot a gun or a bow, I'm going to say probably a good chunk of you have, you have to account for how far away you are. You cannot just aim straight at something if you're decently far from it. You have to take into consideration that that arrow or that bullet, especially arrows since they don't go quite as fast, but it's going to drop some. You can't aim just right at the bullseye if you're, if you're several, you're way, I don't know, several hundred yards back. I'm not super experienced with shooting bow, but if you're a lot far enough back, you've got to account for that. I know that much from what I've done. So, but we have two components of projectile motion. One is horizontal and one is vertical. So the horizontal motion that we have for any projectile is whatever is pushing that object out, is propelling it or being thrown. So it's what's parallel to the ground. So remember, horizontal means side to side. So if you throw a ball, for example, the force that your hand puts on the ball, that's the horizontal component. So we have, you are pushing that ball forward with your hand, and that's the part that makes that ball go forward and it makes it go horizontal. If you look in the picture, the cannon is the force of that cannon is what's pushing it out straight. You can see the path it would take if there was no vertical component with that dashed line, but it just goes straight out because of that cannon's force. Now the vertical motion is whatever's perpendicular to the ground, so it's what's going straight down. And what causes that every single time is gravity. So gravity's pulling it down towards the earth. So if there was no gravity, that object would always just go straight, like the cannon in the picture. It would always go straight. But because there's gravity, it's being pulled down at the same time as it moves forward, and that's what creates the curved path of projectile motion.